Okay, moving forward. Question C says f of z is equals to exponential z. This one you normally see it in your exam. It normally come out. Yeah, it will always be there because, but then they don't normally give it this way. Yeah, they normally give it in the form when they have already compressed it like this. But it's good you also know this one so that in case it comes this way, you'll not be confused. We know very well that exponential z will mean exponential s plus iy, in the sense that z is s plus iy. Now, one can still convert this to this way. How? Let me explain. You can still ask me if you don't understand in the comment section also. So exponential s plus iy means exponential s times exponential iy. You see that? So exponential this exponential x now, it will go separate. Then exponential iy would also come out separate. It is that exponential iy that gave us cos y plus iy. Plus I sine y. That's the definition of exponential I theta. Exponential I theta means cos theta plus I sine theta. You see that? Now exponential iy means cos y plus I sine y. So that's where how we arrive at this. Having arrived at this now, we need to make sure we separate all the complex, to make everything look simple so that we can be able to find out our real and imaginary. And how do we do that? Open the bracket first. You have exponential s cos y plus I exponential s sine y. In that case, when you do that, you see that your real part is exponential s cos y. This one now. The imaginary one is exponential sine y. That's this one now. Remember, I expanded this, before I arrive at this two. You see? And note, I don't need to add this I, so that you're not be asking where the I went. So you have your two equations now, u and v. So how do we now get our distance? Ux equals to this. How do we get us? By differentiating this with respect to s once. When you do that, exponential x will still remain exponential x. Yeah, because we are differentiating with respect to x, we're keeping y constant, only working with exponential s. And remember, the derivative of exponential ax is a exponential x. Derivative of exponential 2x is 2 exponential s and 2s. But now, since this thing is just 1x here, it's 1 exponential 1x. You see that? So it remained the same thing, nothing changed. Uy, with respect to y now, our focus now is on cos y because we're looking at y. Differentiating cos y will give you minus sine y. You see that? We're not going to touch the x. We look at u and v. V sub x, differentiating v with respect to x, that's touching just exponential x, which will give you the same thing as exponential s, and then maintaining sine y, since sine y will be a constant in this case. Now, v with respect to y, if you differentiate sine y now, you have cos y. You will not be touching x in this case. You see that? So that's how we arrive here. Now, we want to check. We need us to be equal to vy. Are they equal? Yes, they are equal. You see that? We also need uy to be equal to negative vx. Are they equal? Yes, they are what? Equal. When you say minus this equals to minus of this one, you say they are equal. So it is Cauchy-Riemann. And because it's Cauchy-Riemann, it's automatically what? Analytic. And when you check this thing that they said, you put these stuffs here, your us, put it, your vs, put it inside, and this thing will end up giving you this. We don't even need this, so just know up to this point you are done. But if they ask you for this, that's why I'm doing this. So you may just need to do it. Just replace this and this. You are just done. You see. If you want to know how this one was gotten, assuming they ask you to give in form of z, just bring out exponential x. It will go out. Remember, I told you that cos y plus I sine y, same thing as exponential iy. You get. So when you have exponential s and exponential iy, you will add up their powers. It will give you this. So that's how it is done.